The Honorable Heidi Shue is the Undersecretary of Defense for Research and Engineering, a position she's held since 2021, and the second for which she was nominated by a president and confirmed by the Senate. In the first, she served as the Assistant Secretary of the Army for Acquisition, Logistics, and Technology from 2012 to 2016. Ms. Shue's expansive background includes deep acquisition experience and mission-critical work spanning radars, unmanned systems, antenna technologies, and more. She's one of the most respected leaders in the defense technology community, and we are so appreciative she could make it to the ERI Summit. Please join me in welcoming the Honorable Heidi Shue.
Good morning. Thank you, Dr. McCants, for the kind introduction, and thank each one of you guys for being here today. I also want to thank you for getting me out of the Pentagon. The weather here is far better. Okay. I'd like to start out by thanking the DARPA team for hosting such an important conference. I applaud the choice of Washington State, one of our nation's foremost technology innovation hubs in the private sector and in the government as well. Okay. The research and development organizations in the Department of Defense are well represented in the state. Certainly, University of Washington Applied Physics Lab, one of our university-affiliated research center, is located here, as well as Office of Naval Research in Seattle, the Army Medical Research Directorate at Joint Base Lewis McChord, and the Naval Undersea Warfare Center in Keyport. Thank you all for what you do. As Undersecretary of Defense for Research and Engineering, I serve as the Chief Technology Officer for the Department of Defense. It's my responsibility to maintain and expand our nation's technological advantage over our adversaries, now and well into the future. Our investments in science and technology spans across a wide range of areas, from emerging technologies like future wireless to effective adoption areas where there exists a vibrant commercial activity, including areas like trusted artificial intelligence and autonomy, to integrated network systems of systems, certainly microelectronics, advanced computing and software, to areas that's defense-specific, like hypersonics and directed energy, and integrated sensing and cyber. One thing that is fundamental and underpins all of these technologies is microelectronics. In FY24, the presidential budget request, my office is in the area of S&T and prototyping fund, namely the 61264 pot of funding, across the 14 critical technology areas. If you take a look at that, due to the foundational nature of microelectronics, it is the biggest slice of the pie. Okay? It is a quarter of the $6.9 billion request. Okay. The rest of the critical technology areas are enabled by advances in microelectronics. We all remember the challenges we faced around microelectronics a few years ago during COVID. A member of my team recounted a trip to Detroit back then, seeing the runway of a regional airport packed full of cars, bumper to bumper, fresh off the assembly line, except for one critical missing component, which is the microchips. Okay. The auto industry alone lost $210 billion in 2021. So you can well imagine how critical this problem could become if a major conflict breaks out and our supply chain of advanced microelectronics is disrupted. The fragility of this critical supply chain will have significant impact both in the defense and commercial industry. Okay. As Secretary Austin has stated, weapon systems employed on the battlefield today and emerging technologies of tomorrow depends upon our access to a steady, secure supply of microelectronics. Since then, the American invention of semiconductors, the United States have gone from creating nearly 40% of the world's chips to just 10%. Okay. For national security, we must lessen our dependence on foreign supplies. The CHIPS and Science Act passed last year is providing us an opportunity to change the direction of that vector. The $53 billion CHIPS Act, appropriately named, creating helpful incentives to produce semiconductors, will motivate onshoring of foundries and reduce supply chain disruptions. I'd like to thank Representative Adam Smith, the ranking member of the House Armed Services Committee, and the rest of Congress at large for their bipartisan work to pass this critical piece of legislation. For the DoD, this means reliable access to secure microelectronics. Expanding our domestic microelectronics infrastructure is a top DoD priority. My office received $2 billion over 5 years to establish the Microelectronics Commons framework. We work in close collaboration with the Naval Surface Warfare Center, Crane Division, and the National Security Technology Accelerator, NSTXL, to execute the Microelectronics Commons program. Okay. The Commons is tackling several distinct technical challenges by creating a national network of regional innovation hubs and core facilities that's distributed across the country. And it is comprised of a diverse set of partners in the commercial sector, the defense industrial base, nonprofits, federally funded research and development centers, academia, and consortia. The companies involved will span across a wide range, from small to medium to large. Okay. The end goal is to reduce barriers to innovation, mature emerging microelectronics technologies, enhance existing microelectronics infrastructure, and grow a pipeline of domestic talent for both the commercial and defense industries. These hubs will help us to connect the researchers and designers to prototyping capabilities targeted to regional strength in the hub's technical area. Hubs will provide lab-to-fab opportunities for innovators to mature emerging microelectronics technologies. The key technology areas that we're focusing on span across multiple applications, from electronic warfare to quantum to future wireless to artificial intelligence hardware to secure edge and Internet of Things in terms of computing, emerging commercial leap-ahead technology. We're interested in all of that. In terms of core facilities, they will provide the hubs with access to scale to greater than 200 millimeter tooling for prototyping silicon-compatible technologies and greater than 100 millimeter tooling for compound semiconductor technologies. Core facilities are required to demonstrate prototypes with a volume and characteristics that's required to ensure reduced risks for full manufacturing production. They will provide hubs with access to repeatable processes and scalable capacity beyond what the regional hubs can provide. Core facilities will enable and facilitate engagements with industry and consortia as well to mitigate risks of integrating new technologies with commercial state-of-the-art processes. The Commons program will help to create direct pathways and opportunities to commercialization for U.S. researchers and build a sustained public-private partnership for sources of emerging technology to manufacturing facilities. This can accelerate early-stage research to create proven technologies in domestic foundries. In addition, the Commons program will help to train and build our talent pipeline for the next generation of semiconductor workforce by enhancing microelectronics education. This is critical to foster and grow a vital engine of our economy. We look forward to sharing more exciting news on this soon. Okay. I would like to highlight a few other microelectronics activities that we have that's ongoing within my organization. The second phase of the Rapid Assured Microelectronics Prototype, or RAMP program, was awarded to Microsoft in November 2021 to bring state-of-the-art microelectronics design and manufacturing to national security and defense application while ensuring these components are developed with the utmost regard to security. Okay. Microsoft is working across commercial and defense industry and will develop custom integrated chips and systems on chip designs using a secure collaborative design flow that provides access to advanced manufacturing processes. By leveraging cloud-based secure design capabilities, RAMP will expand the number of foundries that's available to the DoD while enhancing resiliency. We also manage a Rapid Assured Microelectronics Prototypes Commercial, or RAMP-C program. The RAMP-C program was created to facilitate the use of a commercially viable onshore foundry ecosystem that will ensure DoD access to leading-edge technology, while allowing the defense industrial base to leverage the benefits of high-volume semiconductor manufacturing and design infrastructure of the commercial partners. This program allows the commercial foundry customers and the DoD to utilize Intel's leading-edge process, Intel 18A. Intel's partner with IBM, Cadence, Synopsys, and others to support the DoD's need for designing and manufacturing assured integrated circuits. RAMP-C provides assured access to the leading-edge semiconductor design and manufacturing. On the packaging side, we also manage the state-of-the-art Heterogeneous Integration Prototype, or SHIP program. The SHIP program will enable the DoD to access Intel's latest commercial advanced semiconductor packaging capability. The SHIP program partnered with Intel and Qorvo to develop prototype devices for DoD systems that demonstrated significant size, weight, and power savings. In April of this year, the first two types of multi-chip package for SHIP Digital was delivered by Intel, and multi-chip module for SHIP RF was delivered by Qorvo. These chiplets will allow mixing of RF devices with standard digital devices, which enable us to reduce size, weight, and power, or SWaP. The SWaP reduction that's enabled by these chiplets will provide significant performance benefits for the next generation of integrated systems. Okay. These important initiatives will allow us to leverage commercial technologies to expand our access. But we're not stopping here. DARPA, the DoD's premier office of disruptive innovators, unfortunately got disrupted yesterday, I heard, okay, is leading the charge on Electronics Resurgence Initiative 2.0. DARPA will initiate novel high-risk, high-payoff programs to discover new methods for designing, fabricating, packaging, and testing complex 3D microsystems. We need this type of innovation across a wide swath of our future systems to stay ahead of our adversaries. There is no shortage of innovation in this country, and we must accelerate transition of the latest technologies into the hands of our warfighters to deliver new capabilities and to give our warfighter an asymmetric advantage. I would like to highlight a few different ways that my office is helping to accelerate transition at speed and scale. In the last 2 years, we trailblazed the accelerated procurement and fielding of innovative technology. The acronym is AppFit. Okay. This is a pathway program. We identify small businesses and non-traditional businesses that demonstrated innovative prototypes, which our services and combatant commands would like to procure. But the programming process created a 2-year gap in funding. As you guys well know, we first demand you guys demonstrate capability of your prototype, and then we decide we really would like to have this. Then we budget for it. Well, guess what? We're in a two-year budget cycle, so therefore you have to hurry up and wait for 2 years. Okay. Very hard for small companies to sit tight for 2 years waiting for a contract award after you demonstrate capability that the DoD wants. Right. So last year we awarded 10 small companies, $10 million each to accelerate delivery of capabilities by 2 years and to ramp up their initial production. A couple of examples that I'll share with you. For example, we funded a small company that developed advanced sensors to be able to detect naval mines. And it is being implemented for underwater UUVs, basically. Okay. Another small company developed a vertical takeoff and landing UAS that can land on boats in very high wind and high sea state conditions. Another small company developed a wide field of view night vision goggle, twice as wide as the current system. Not only is a wider field of view, it's lighter and higher resolution. So you can well imagine all these small companies has delivered very innovative products that the services want right now. Okay. So this year we identified 11 companies and awarded contracts ranging from $10 million to $20 million. We funded a company to produce a rapidly deployable shipboard carry-on satellite communication terminal that allows connection to multiple commercial satellite constellations to create resiliency to the military satellite communication. Okay. We also award a small company to produce a mixed reality virtual trainer for the naval aviators. That's 1/3 the cost of the traditional simulators. Okay. The other pathway that we have created is via the Rapid Defense Experimentation Reserve. Sometimes you hear us call it RADAR. Okay. RADAR takes the joint warfighting concepts that's developed by the joint staff and seeks innovative prototypes that we can demonstrate in a joint experimentation to demonstrate military utility. Okay. We collaborated very closely with the services, combatant commands, joint services, as well as industry. The first set of experiments that was identified 2 years ago, we had to wait for the funding, right? So this year, after the CR, we finally got the funding, we're able to get going. Okay. We conducted experimentation at Camp Atterbury in Indiana. The prototypes that successfully passed through the first set of experiments went on to Northern Edge for military utility testing. So once they demonstrate effectiveness there, we will present the findings and recommendation for rapid fielding decision this fall. Okay. So we have collaborated very closely with the Office of the Undersecretary Acquisition and Sustainment, Dr. Bill LaPlante's office, and they have identified pathways to help us to accelerate the capability delivery. So this is pretty exciting. Okay. The DoD also sponsors 9 manufacturing innovation institutes. The goal of the MIIs is to develop innovative manufacturing technology to provide commercial competitiveness and national security of DoD industrial base. Some examples of the MIIs are NextFlex. They are focused on the manufacturing of flexible hybrid electronics. AIM Photonics, they're developing integrated photonics. BioFab USA is developing a modular enclosed tissue foundry, namely tissues going in the beginning, organs popping out the other end, okay, or nerves. Very, very exciting. America Makes is focused on establishing additive manufacturing standards and providing a secure way for us to share the 3D printing files across the DoD to the point of need. Okay? Again, underlying all of these capabilities are advanced microelectronics. Okay? So I've given you a glimpse into a few of the activities that my office is working on. Innovating the future of microelectronics is exactly where you can contribute to this exciting new DARPA initiative. Together, we have the potential to catapult the U.S. technological leadership and safeguard our future national economic security. Our ability to design, fab, assemble, and test microelectronics in the United States is essential to protect this nation from malign foreign influence. I cannot understate the importance of having trusted parts free from counterfeits. Thank you all for what you do.